We're talking about equivalent fractions right now. On equivalent fractions, that's fractions that are equal to each other. And it's very simple. On problems 1 through 6, multiply or divide to find equivalent fractions. Problem number 1, what they're doing is they're multiplying the numerator and the denominator by 2. Or by 3, I'm sorry. So 2 times 3 is 6. And 3 times 3 is 9. So that's saying that 2/3 is equivalent to 6/9. Problem number 2. On problem number 2, they're dividing the numerator and denominator by 5. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So 5/10 and 1/2 are equivalent fractions. Another thing about fractions that are equal to a half. Something that's real. 1/2 is a benchmark fraction. That's a fraction that we use a lot and we should be very familiar with. And if you try to figure out if a fraction is equivalent to a half, if the numerator is half the denominator, that fraction is going to be equivalent to a half. Or vice versa, if the denominator is twice the numerator, it's going to be equivalent to a half. So a half we use a lot, and you should know everything that's equal to a half. Problem number 3. And those aren't highlighted green, but I'm going to do those anyway. I must have erased them. But 5/6 is equal to how many twelfths? How many twelfths? And to get from 6 to 12, we're going to multiply by 2. So that's times 2. So if I multiply the bottom by 2, I need to multiply the top by 2. And 5 times 2 is 10. So 5/6 is equal to 10/12, or equivalent to 10/12. On problem number 4, they basically just did the inverse operation. They took 10/12 and we're trying to make it into how many fifths. So to get from 10 to 5, we divide by 2 instead of multiply by 2. So if I do that to the numerator, I got to do the same thing to the denominator. And 12 divided by 2 is 6. So 10/12 is equivalent to 5/6. Problem number 5. 3/12. I'm trying to figure out how many fourths that is. So to get from 12 to 4, I'm going to divide by 3. Divide by 3. So if I do that to the denominator, I need to do the same thing to the numerator, to the numerator. And 3 divided by 3 is 1. So 3/12 is equal to 1/4. Problem number 6. 3/4 is equal to 9 something. So to get from 3 to 9, I'm going to multiply by 3. So 4 times 3 is 12. So 3/4 is equivalent to 9/12. Problem number 7. Suppose a pizza was cut into 12 equal sized slices. 3/4 of the pizza is left. How many slices are left? Explain. That's going to be a problem very similar to these problems that we're working on right here on the left. So we've got 3/4 of the pizza left, and there were 12 slices total. It was cut into 12 equal pieces. So to get from 4 to 12, we're going to have to multiply by 3. That's times 3. So if I multiply the denominator by 3, I'm going to multiply the numerator by 3. 3 times 3 is 9. So that means that there are 9 pieces of pizza left. You're not seeing that, it's not showing up. But that's 9 pieces. I'll put 9 equals P, which is pieces of pizza left. Problem number 8. Okay, Josh, Lisa, and Vicky each ate half of a pizza. Okay, their pizzas were the same size, but Josh ate 1 slice, Lisa ate 3 slices, and Vicky ate 4 slices. How is this possible? And I'll show you. Okay, I'm going to box in my question. Okay, I got to tell how this is possible. And I'm basically going to talk through this, and I'm going to show you how I do it. So they all ate half their pizza. They were all the same size pizzas. But Josh ate 1 slice, Lisa ate 3 slices, and Vicky ate 4 slices. I'm going to go ahead This is Josh's. He ate one slice. That's the part they're asking about. That's the numerator. And that's telling me that there were 2 total pieces. They cut it in half. On the next one, Lisa ate 3 slices. She ate 3 slices. That's telling me that the pizza was cut into 6 equal pieces. And Vicky ate 4 slices. And that's telling me that her pizza was cut into 8 equal pieces, 8 equal slices. And the reason I know that is they say that each of them ate half their pizza, and we already talked about fractions that are equivalent to a half. So that's how we know how many pieces the pizza was actually cut into. Okay. Problem number, we're going to work together on the even problems, and you're going to go back and do the odd problems on your own. So problem number 10. On problem number 10, we got 9/12, and they're dividing the numerator and denominator by 3. So 9 divided by 3 is 3. Who can tell me what 12 divided by 3 is? Kevin?
4.
4. So 9/12 is equivalent or equal to 3/4. Problem number 2. They're dividing the numerator and denominator by 2. 2 divided by 2. What's 2 divided by 2? Connor?
1.
1. Good. And what is 4 divided by 2? Logan?
2.
Good, good. Just thinking for a second there. So 2/4 is equal to 1/2. Okay. On 14, they're not telling us what to divide or multiply by. But what would I do to 3 in order to make it 6? Ishmael?
You have to multiply.
And what would I multiply it by, you think?
Times 2.
Times 2, that's right. So if I do that to the numerator, I got to do the same thing in the denominator. So 4 times 2 is 8. So 3/4 is equivalent to 6/8. Similar problem on 16. We've seen back here on problem number 14 that we had to multiply by 3 by 2 to make it 6. So it's still times 2. So 5 times 2 is 10. Okay. Down here at the bottom, problem number 18. On 18, they're just trying to tell us to find equivalent fractions. What's one way we can make an equivalent fraction? What's one way we can make an equivalent fraction? Okay. You can either multiply or divide to make an equivalent fraction. Either multiply or divide to make an equivalent fraction. So on number 18, I'm going to decide to divide. I'm going to divide by 2. I'm going to divide by 2. It's always easier if you multiply. If you're trying to create a equivalent fraction, it's always going to be easier to multiply because we don't always know the right number to divide by. But on this one I do. I'm very familiar with my fractions. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So that's saying that 2/10 is equal to 1/5. On problem number 20, I'm going to multiply by 2 this time. So times 2. 3 times 2. What is 3 times 2?
6.
6. And what is 5 times 2? Caden?
10.
5 times 2 is 10. Good. So 3/5 is equal to 6/10. Let's go ahead and look at the back page now. Problem number 22. A teacher asks his students to name 5 different fractions that are all equivalent to 1/2 and have an odd numerator. List 5 fractions that the students might have given. So they're equal to 1/2. I'm just going to go ahead and write my numerators down because they say they had to be odd numerators. So I'll go with 3, 5, 7, 9, and 11. Okay, what would the denominator be for the one with the numerator of 3, you think? What do you think the denominator would be for the one that had a numerator of 3? Okay, Nathan.
4.
4? Okay, anybody, any other ideas? Connor.
Caden.
Caden.
1.
1. Kevin.
6.
6. Remember, they all have to be equal to a half right there. So our denominator is going to be twice our numerator. So that means I have a 10 as a denominator here, have a 14 as a denominator here. Why am I going to have it as a denominator for my 9? Reese.
18.
18. And 22. So those are all equivalent to a half because my numerator is half my denominator, and they're all odd numerators. Problem number 24. Okay. Henrietta bought a photo album shown below. She paid with a $20 bill. How much change did she receive? So she paid with a $20 bill. I'm boxing in my question. And the photo album costs $8.29. $20 bill. Important to make sure you line up your place value. Okay, and $8.29. Subtraction problem if I'm trying to figure out how much change I'm going to get back. So, I have to regroup. I cannot regroup in the tenths place. I can't regroup in the ones place. I got to go all the way to tens place to regroup. That's going to be a 1. That makes my ones place 10. Now I can regroup that. That'll be 9. And my tenths place will be 10. I regroup that, and that'll be 9. And my hundredths place is now 10. I can subtract. 9 from 10 is 1. 2 from 9 is 7. Bring down my decimal. 8 from 9 is 1. And 0 from 1 is nothing. 1. So that means she would have got $11.71 change back. Problem number 26. Okay, if 50 of the 50 states, 2/5 of the states start with the letter M, A, or N. How can you use equivalent fractions to find out how many states this is? So we're going to go ahead and box in our question. We're going to try to figure out how we can use fractions to equivalent fractions to figure out how many states start with M, A, or N. So there's 50 states total, and 2/5 of them start with M, A, or N. So 2/5 of the states, and we know the total amount of states there are 50. So what would I do to 5? What would I do to 5 to make it 50? What would I do to 5 to make it 50? Maya.
Multiply by 10.
Multiply by 10. So times 10. So if I do that to the denominator, I have to do the same thing in the numerator. So 2 times 10 is 20. That means there's 20 states. 20 states that start with M, A, or N.